please welcome Dr. Marc Raibert, co-founder of Boston Dynamics and executive director of the AI Institute.
I am so glad to be here. I really love robots and AI, and it is a fantastic time to be, a really remarkable time to be in the robotics and AI business. There's so much going on, some of which I'll tell you about, and what could be better than to be at this, at the pinnacle, at least the pinnacle till now, of a field like this. Now, I don't know where the title 100 years, the next 100 years of robotics came from. Some of the things I'm going to talk about may look forward to 10 years, but the way things are going, you know, that could be just 2 years, and things are moving so fast now, both on the robotics side and on the AI side. I think the convergence is still something that's really evolving, and I'll talk a little bit about that. Now, when I think about intelligence, I think about it as having two kinds of parts. One part is the athletic part, the physicality of the system, whether it's a person, an animal, or a robot, and their ability to maneuver in real time in the world, perform real-time tasks, the fast interaction between their bodies and the worlds around them, their ability to conserve their energy, to use their bodies to get maximum strength and forces and things like that. But there's another kind of intelligence, which is, I think, what people more normally think about as being intelligence, and we think of it as going on in our heads, making plans. Like, I had to be here today by 9 o'clock. I really wanted to get here by 8:30. I looked up how far it was from my hotel to here, and I made a plan of what time I had to get up, how long it was going to take me to get dressed, and all that kind of stuff. And we do that every day, some of it without thinking, and you know, computers are starting to be able to do that for robots and other kinds of systems. So in this talk, I'm going to start out talking about mostly about the athletic side of intelligence, and I'm going to talk about work that's going on at Boston Dynamics. I'm not actually at Boston Dynamics anymore. I'm on their board, but day to day, even though I ran the company for close to 30 years, in fact, the 32nd anniversary of the company is coming up in a couple of weeks. And then I'm going to talk about cognitive intelligence and combining it with athletic intelligence in the context of a new organization that has just been around for 2 years, the AI Institute, which is a separate thing from Boston Dynamics, but it has many similar goals. So just as a piece of context and history, this is a robot that was developed starting about 20 years ago at Boston Dynamics. I'm sure most of you have already seen this and maybe seen this exact clip on YouTube. It's a dynamic robot. It's sort of the first almost productization of a robot that moves dynamically and balances itself, as opposed to a slowly moving robot. One of the things about this whole series of robots, this one, let me turn up the sound a little bit. This robot and this one, this is called LS3. These were funded by the US government, by DARPA, some by the Army, ONR, and they really got involved very early in this technology and kept the embryo alive before it was really a practical thing. And it took many years to go from the first versions. I didn't even show you the first things we developed. You know, it was probably 30 years or even more than that till today when these things are starting to look like things with practical applications. This is the fastest legged robot, a thing that runs and flies a little bit like an animal. We call it Wildcat. It's also probably the loudest legged robot in the world. We had people 3 buildings away complaining about the noise on a regular basis. And then this is the beginning of the transition to the product robots, one of which I'm going to talk about, and I think you're going to get a live demo of it later this afternoon. So part of the reason I'm here today is to connect with this community that's closer to the DARPAs and ONRs that are taking the seed of an idea and funding it so it can possibly grow into something useful for the country and for humankind. Now, this is a video made at Boston Dynamics, which is a vision of how robots eventually will be integrated in warehouses and in factories. This is a robot Stretch, and this is just animation of these robots. In a few minutes, I'll show you where we are in the development of each of these robots. But there's about 500 billion boxes unloaded from trucks, loaded into warehouses, sorted and resorted, and then shipped out to stores, 500 billion a year. And right now, most of it's done by hand. So this is a robot that can do some of the work of handling those boxes, something that's really not automated now. This is a concept for a factory where parts are being sorted and handled in anticipation of assembling them into products like cars and other things. In this scene, we're showing a humanoid robot, a four-legged robot, and then you saw the package handling robot before. And these are all things at various stages of development at Boston Dynamics. So again, this is just a vision of the future, of a practical future for the use of these robots, even though a lot of the work is at various stages of R&D, productization, robustifying, and the like. So I'm going to talk about those three robots briefly. This is the Spot robot, a four-legged robot, and you're going to get a live robot demonstration of Spot later. Brendan from Boston Dynamics is here, so I'm not going to talk as much about this as I usually do, but I'll just say this is a very interesting robot because when we started selling it, we didn't know how it was going to be used. So we made it so it was adjustable for each user. We have a roof rack on it where you can attach your own hardware. There's an API, and at the bottom is shown some of the hardware that can be attached to the robot to customize it for your own application. And here are some of the actual applications of this robot. Brendan, again, will tell you more about them. But one of the big ones is law enforcement, where this robot is used to de-escalate very dangerous engagements, and it's used by several SWAT teams around the country and other kinds of, not only SWAT, but also bomb disposal and other kinds of uses. I won't go into all of them, and I hope Brendan can tell you more later. But I will say there's about 2,000 Spots out there. You know, for a real consumer product, 2,000 isn't a very big number, but for this kind of articulated robot, that's a very successful product. And we're really excited to see how it's being used out there. Now, there's other companies developing quadruped robots, and I think that shows a level of maturity in this kind of robot. The question isn't all, do I want a legged robot? It's becoming more, which one should I buy? And I'm really pleased that that's where we are. And I saw an Anybotics robot this morning. We have some at my new institute also. It's another great one. Ghost is one that's selling largely to the military, and Unitree is probably the most successful Chinese quadruped robot. And I can tell you more. I'll be here this morning, so if you want to talk more about these things, I'd be happy to fill you in. Now, Stretch is possibly the most practical robot that Boston Dynamics has developed. As I said before, there's about 500 billion boxes handled around the world every year. That's a big number, and it's almost all done manually, including unloading and loading trucks, palletizing, depalletizing, and the like. And so here's just a little clip showing Stretch at work. This robot was purposely designed to perform these tasks of handling boxes, particularly having a vision system that can see the boxes, select one or more to unload. It has although it has a suction cup hand that's very specialized and has a lot of specialized capabilities for this. And it's being tested in real warehouses. I don't know the exact number now, but there's been millions of boxes handled in these warehouses at DHL, at Maersk, and other places. And it's gradually turning from a proof of concept into a real money-making product for these companies. Here we're showing handling multiple boxes at once. And again, I can tell you more about this later if you're interested. Atlas is the robot that's closest tied to the future, to that 10 years that's unfolding. And again, some of these clips you've seen before. This is one that's on YouTube with a robot out in the wild, moving. I wanted to point out this is all shown in real time, and there's no teleoperation in anything I'm showing. I know some of you who are paying attention to this field know that getting an understanding of what's actually going on is one of the challenges. This robot has very advanced athletic skills. I wager that even some of the people in this room can't perform the athletic activities that the robot's doing. I'm not going to even show the backflips, which the robot can do. And the level of balance accomplished in the control system, the athletic intelligence of the robot, is really remarkable. You know, we're not abusing this robot. We're proud parents showing off its capabilities when we do this kind of thing. But I wager if we push that hard on most of you, you'd be lying on the floor or sitting on the floor. Oh, I screwed up here. Lately, I've been showing this clip. This is a very recent clip showing Atlas doing as nearly as it can to a real productivity task. And I want to point out that everything here is autonomous. I'm not saying that there weren't programmers involved in programming the task, but once it was programmed, everything here is autonomous. It's moving in real time. It's navigating. It's using its vision system to see the parts that it's handling and figuring out how to pick them up. It's using two hands to lift the parts that need to be stabilized that way. So there's a huge amount of progress being demonstrated here, and this is very close to useful for industrial tasks, like making cars, but really for many other things. It's not quite there yet. There's lots of pieces to the puzzle, but I think I'm really proud of what the group at Boston Dynamics has done in showing off these capabilities. This is a mock-up of an actual car production task where pieces of a car that have been assembled are organized into the different types because there's multiple different kinds of cars coming down the assembly line, and then the robot's sorting them for the particular car that's coming right now. And again, this is just a lab mock-up of that task, but you see we're getting pretty close to making it so that this could be used in the real world. Now that was the old version of Atlas. This year, Boston Dynamics has started to tease what the new version will be like. This is an all-electric one, where the previous one was a hydraulic powered robot. And there's lots of exciting things about this that I'm not allowed to tell you about, but stay tuned and you'll see all kinds of cool things happening with this robot. Here it's doing a little PT. Now, as I said, it is an amazing time to be in robotics. These are some of the American companies making so-called humanoid robots. I was just talking to the agility guy, and I think he's giving a talk later today. Obviously, Tesla is in it, and several others, Figure, Aptronic. There's several companies in Europe. I'd say there's a little less activity there, although there's some very strong companies working there, especially, I think, 1X. And as someone said, China is just going nuts. I was there a month ago. This was taken in the spring at a conference where they showed 17 different robot companies making humanoids. But I was there a month ago and was at the World Robotics Conference where there were 30 companies, or 27 companies, demonstrating their humanoid robots. And later I can tell you more about sort of the level of technology and what I think the prognosis is. But I think an important question to ask is, are humanoid robots the best idea? And the answer to that, I'm going to leave that as a hanging thing, as a rhetorical question, but I think the answer to that depends upon your timeline, your funding, your goals in life. My goal, I love robots and I want to climb the Mount Everest of robotics, and so I'm working on humanoid robots. But if your goal is to get a product out in 2 years and be making money in 3 years, maybe not so much humanoids. And there's everything in between. So we could talk about that later if we have a conversation. I only have 5 minutes left, so I'm going to just give you a little idea about work on the cognitive side that we're doing at my new organization, the AI Institute. My goal for the AI Institute is to be the Bell Labs of robotics and AI. It's a pure research place where ideas and talent are at the core of everything we do. And our goal is really not to solve today's or even tomorrow's problems, but to figure out the hardest problems that are really going to enable the field if we can make progress on them, the 5-year problems and maybe even the 10-year problems. I don't know about the 100-year problems, but and we've designed it to be halfway between a corporate lab and an academic lab. You know, have the scale, the teamwork, and the some system engineering of a corporate lab, but with the ambitions and the talent and the disregard for the legacy of an academic lab. Here's some of the kinds of ideas that we're working on. You know, it takes a whole room full of very skilled programmers to program a robot to do even the tasks that I just showed. And if any of you came to a car factory, we could find a job, a useful job, where we pointed at someone else doing it, and you could watch them for, you know, do on-the-job training for 10 minutes or an hour or whatever it was, and you'd be able to do that. And we should be able to program robots that way too, where they watch someone do the task, understand what they're seeing, and that's a big task, and then do it themselves. And it doesn't have to be, this is the robot doing it itself after watching that guy. It doesn't have to be an industrial task. It could be a task in a home. I don't think robots in the home, or at least humanoid robots in the home, is anything that's going to happen very soon because of cost, safety, functionality, and things like that. But I think that the technology that supports it in industry will also be useful in the home. The next layer of aggressive goal is to be able to make robots that can inspect, diagnose, and fix. That is the drawing of an actual place that I worked 50 years ago when I was a co-op student. And that's a drawing of an actual robot that is now working at that facility, collecting data by doing patrols. So that's one of the customers for Boston Dynamics. But all it's doing is collecting data so that humans can analyze it. The robot should be able to analyze the data, decide whether a machine is working right, and then diagnose what's wrong if it's not working right and fix it. I know that's a long ways off. This is science fiction today, but it's the ambition of the kind of work we're doing at the AI Institute. And of course, there's domestic versions of this. I just had some guy had to spend $500 getting my refrigerator fixed because it was freezing the fruit. That was just 2 weeks ago. And you know, a robot should be able to do that. Dexterous mobile manipulation is really an important ingredient that crosses the boundary between the physical skills and the intellectual skills that we've been talking about. And there's just a huge number of applications. We're starting to make progress. Here's some work we did where we teamed up with Boston Dynamics. They gave us very low-level access to their Spot robot, and we applied reinforcement learning techniques, actually, interestingly, techniques that in some sense were developed using the Anybotics robot. But here we used them to get Spot to go about 2.5 times as fast as the released product. So it gets up to 5 point something meters a second, which is pretty fast. You can see the guy is having to work to keep up. We're starting to apply that to the humanoid form. So here's a task where the humanoid robot has to, this is in simulation, obviously, and in fact, we simulate millions of cases before we start testing it on the physical robot. There's the popular sim to real gap that we have to deal with. Here's another task where the robot's climbing out of a deep hole. And here's the training regime that's used to teach something like that. We don't start out with it having to do the hardest case. We give it some opportunity to learn on an easy case. It's pretty much like you'd teach anybody to do anything. And then eventually it can handle the worst case. We haven't tested this in hardware yet, but we hope to do that in the next couple of months. And there's lots of other potential applications. at various levels of feasibility, cost, value that we're working on. I think it'll be a while till we're helping human beings at home get in and out of bed, which a lot of people need help with, which is very expensive. But other things like having people, I get email all the time from people who are in wheelchairs who would like to still be able to go out for a hike, and I think that could just be right around the corner, and we have a group working on that. We do also have an ethics and policy group at the AI Institute that are looking at some of, there's a bunch of challenges in ethics and policy of robots. In fact, this audience probably knows more about it than I do, you know, regulation, safety, things like that. And I think getting a good balance between the risks and the opportunities is important. And there's relatively little hard data on these topics. And our mission is to collect some hard data so that people making decisions, like regulators, can have something really to base their decisions on, and it not all be what's in the media, which I think is very loosely connected to what's going on in the world. I'll skip this. This shows the low reproduction rate in much of the developed world and how that is helping motivate the need for robotics, but is also obviously related to the ethics and policy of what's going on. That's all I have. Thank you, and I'll be here if you want to talk about it some more.